Yo, welcome back. Today's lesson is estimating population measures of center. So first, let us use samples to estimate measures of center for the population. Would you use the median or mean to describe the center of each data set? Explain your reasoning. All right, so go ahead and work on that. And then discuss it with your partners, and then we'll come back and take a look. All right, so basically when we look at this data, the main thing we want to take away, or one thing we want to take into account, is that the difference in these two types of data. Okay, so we would call this is balanced. Okay, you kind of have the same amount of data on the left and the same amount of data on the right. Okay, that's symmetrical. And over here, the data is kind of skewed to the right side. Okay, so when we're looking at measures of central tendency, the median and the mean, usually the mean is good for symmetrical. Okay, symmetrical data. Symmetric, let's just say symmetric, and that's an M right there. Okay, if you're not sure, so two M's, symmetric or symmetrical data. And the median is good for data, better when data is skewed. Okay, because the mean works well when the data is symmetrical because it accounts for all the values. Okay, so if we're looking at this data over here, the height of the basketball players, it is symmetrical, so it's probably going to be better to use the mean over here. Okay, because it's going to use all the data and balance it out. Okay, now this is skewed, so it's going to be better if we use the median. Okay, because it's not going to be, the median is not going to be pulled by the outlier. Okay. Okay, the median is going to be less affected by the outlier and skew the data itself. All right, so that's the keynote. All right, that's the key point. All right, so let's look at the other two. All right, so let's look at it all of them at the same time. So if we look at the backpack weights for sixth graders, that is also skewed because we have this outlier out here. Okay, so that's like a random high or randomly extra low value. So that outlier out here skews the data. So in this case, it'd be better to use the median. And like this basketball player graph here, this book students read over the summer is pretty balanced. Okay, on this bar chart. So we would give this histogram rather, we would give this the mean, use the mean as I'm looking back at the question. It says, which would you rather use? So for that last one, they're not numbered, but for that last one with the histogram, we'd rather use the mean to find the number of books. All right. Add that to your notes. Move on to the next one. All right. Go ahead, take a moment and read this question. All right. It says 3 different TV shows. Here are the ages and years of a random sample of 10 viewers for 3 different television shows. The shows are titled Science Experiments You Can Do, Learning to Read, and Trivia the Game Show. Calculate the mean for one of the samples. Make sure each person in your group works with a different sample. Record the answer for all 3 samples. Which show do you think each sample represents? Explain your reasoning. Okay. You're going to do that in groups. Find the mean. Okay. So basically, you're going to add all of these numbers up for each of the groups. You add them up and divide by the total number. So you're going to add them up, find the total, and divide. It says 10 viewers. So then you're going to be dividing whatever your answer is, say that's in the box, and divide each by 10. And you're going to do that 3 times, okay, for each sample. Okay. And okay, so let's do it like this. So you're gonna have sample 1, sample 2, and sample 3. Okay, and then you're gonna put the range. Okay, the range is the highest to the lowest. Okay, you'll put that in parentheses, the range. All right, and then you would come up with the mean. So the mean equals whatever that is, the mean equals whatever that is, and then the mean equals whatever that is. Okay, so then down here you're gonna have sample 1 goes with which TV show. So this is the first TV show, the second TV show, and the third TV show. Okay. The TV shows. So then you're going to say, based on the data, you think that sample 2 goes with which TV show, and you're going to do the same thing for sample 3. Okay. Boom. All right, you just put the range there. So you can write the range if you wrote it in the parentheses. So the range goes in that spot. All right. So go ahead and do that. And when you come up with your final answer, we will discuss it as a group. All right. All right. So I'm not going to put the examples in the video because we're going to discuss it in class, and we'll have to have a key somewhere somehow. But I'm not going to put it in the video because the kids will just find the video and fast forward and get the answers and then use that. So we will go over the answers in class, and each group will present what they got, and we will talk about it in class. Okay. So assuming we have done that, then we will move on to the next question. All right. Boom, boom. All right, take a moment to read that. All right, so this is more of the same. Basically, I think it's exactly the same. It's just got new data. So you're going to basically do the same thing. I guess it's more practice. Okay, so add it up, then divide by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 it is. So it's going to be the same thing. So you are going to work with your groups again. Provide the data on a sticky note to me when you're done. And then we will present it to the class and talk about how you got your answers, how you worked as a group to get to the answers efficiently, and what you learned from the data. Okay, so then you will calculate the mean, say sample 4. First you put the range, which is, okay, so this is going to be the range, which is the high and the low. And then you can do over here the mean equals. Then do the same thing for sample 5. Put the range, and then the mean equals. Same thing for sample 6. The range and the mean equals. Okay, and then based on that, okay, you could say sample 4 goes with which TV show, sample 5 goes with which TV show, and sample 6 goes with which TV show. Again, all right, explain your reasoning. We'll talk about it in class, and we'll figure out the details in class. All right, so assuming we did this in class and shared our findings with everybody, let's move on to the next section. All right. For each show, estimate the mean age for all of the show viewers. Okay, so we'll go ahead and do that in class based on your data that you've collected. And next question, calculate the mean absolute deviation for one of the show examples. Make sure each person in your groups works with a different sample. Record all 3 answers. All right, hold on. Okay, so first thing, let's abbreviate. This is going to be learning to read, L2R. This is going to be science experiments, and this is going to be trivia game show. Now we're going to abbreviate this question, and I'm going to give you a data set for each. Okay, so learning to read is going to be 6, 6, 7. That's a 7, 5, and 6. 6, 6, 7, 5, 6. So that's your data you're going to use for that. So let's say learning to read, and let's hope there's enough room to do all this. The mean is going to be equal to 5. Oh no, I said 6. Start with 6. Let me erase it. Okay, 6 plus 6 plus 7 plus 5 plus 6 added up. Divide by 5, giving you the mean. Pause for a second. All right, so where were we? So when you add all that up and divide by 5, you're basically going to get 6. Then you're going to find the mean absolute deviation. Okay, which basically means you subtract 6 from each of these. So 6 minus 6 is a 0, plus a 0, plus a 1, plus a negative 1, but we only want the absolute value. So we'll take the 1 and another 0, which gives, and we're going to divide that by 5, which is 2 divided by 5, which is 0.4, right? Okay, 0.4. Okay. And then we are going to, the MAD right here is 0.4. Okay. And that gives us a better understanding of how spread the data is. Right. Yeah, let you know how spread out the data is. Okay, so then what we're going to do is I'm going to give you some values so you can do the rest. For science experiments, we're going to have 11, 12, 13, 12, and 11. And then you're going to have for trivia game show 45, 55, 50, 60, and 50. Okay, so just like I did here, they're going to do science experiments, the mean and the mad over there, and then you'll do trivia game show, the mean and the mad over there. Tabulate your data in groups and then present it to the class, and then we will take it from there. All right, so go ahead and work on that now. All right, so we will discuss your findings in class, and in the meantime, we will move on to the next data. We'll do the different values for the MAD, tell you about each group. We'll talk about it. Okay, an advertiser has a commercial that appeals to 15 to 16-year-olds. Based on these samples, are any of these shows a good fit for this commercial? Explain or show your reasoning. Okay, we may skip that question. If not, we'll answer it in class. Okay, and then let's move on to this section. So take a moment to read this. All right, we're going to do one of these questions and call it a day. So it says a movie rating website has many people rate a new movie on a scale from 0 to 100. Here is a dot plot showing a random sample of 20 of those reviews. Would you use the mean or median? Would the mean or median be a better measure for the center of this table? Explain your reasoning. We said it before. When you have outliers, that the median is better. Okay, so when you have skewed data, that means it's stretched to the left or the right or high or low, then it's better to use the median because it's not influenced by the outliers. Okay, and again, when you have uncommonly high or uncommonly low numbers, those are called outliers. Okay, if there is symmetry or balance, okay, if the data is neat, okay, or symmetrical, then let's leave it symmetric so it doesn't confuse you, and that's a C right there. Then we want to use the mean. Okay. How would you find a median of this data? It says there's 20 reviews. It means there's 20 dots here. So that means that 10 and 11 would be the center. Okay, the center of the data. So you would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically the two middle data points would be 90 plus 90, and you divide that by 2, and the median would be 90 for this data set. All right, so we're gonna wrap it up there, because in actuality we probably wouldn't have enough time to get this far in the class time. So with that said, if you got any questions, ask me in class, and other than that, peace.